Hi everybody, this is the Math 30-1 functions review, and this is the composition section here, the question 5. So we're supposed to suppose that r is equal to the square root of x minus 2 and that s is 2 times x. And so we're going to determine all of these values here. So to start off with, we're going to evaluate s at r at 6. Now the first thing we got to do here is plug in 6 into r. Okay, so we plug it in for the x there, so 6 minus 2 is 4, square root of 4 is 2. So we can replace r of 6 with 2. Then we move to the s function. Because we've got a 2 there, we simply plug in the 2 for the x, and so this is going to end up being 2 times 2, or 4. Okay, and that's s of r of 6. Now we'll do r of s of 9. Now what I got to do here is plug 9 in to the s function. I need to evaluate what's inside there first. So this will end up being r of, if I plug 9 in, 2 times 9 is 18. And so now I'm going to evaluate r at 18. Okay, so we go to the r function, plug 18 in. 18 minus 2 is 16. And the square root of 16 is 4. Let's try this one. S of r of 5. So again, I'm going to go to my r function and plug in 5. So 5 minus 2 is going to be 3. Okay, this becomes now root 3. So it's not this super nice number, but that's okay. It doesn't change anything. And so now I've got root 3 here. When I go to my s function, if I plug root 3 in, this simply becomes 2 times root 3. Nothing wrong with that at all. Over here, r of s of 5. Okay, so now we're doing this in a slightly different order here. And again, we would expect a different result because we've seen that before, that order does matter. So s at 5, if I go up here, s of 5, I'll just multiply 2 by 5, so I'll get 10. And now I evaluate r of 10, so I plug 10 in for the x here, and I subtract 2, and that is going to end up being the square root of 8. And so that will simplify down to 2 root 2 when I simplify the radical there. Over here, do this with a different function here, s of r of negative 2. So I go to my r function first, and I plug in negative 2. You remember, r is going to be negative 2 minus 2. So it's going to become negative 4, and so it's the square root of negative 4. Now, all of a sudden here, I'm running into a problem. Because I have this square root of the square root of negative 4 there. So there's no real answer to this. There's no real answer. It's going to have to be an imaginary answer, and we're not dealing with that right now. Let's move on to the next one, though, and see if this makes a difference here. r of s of negative 2. Well, s of negative 2, if I plug that in, 2 times negative 2, it's going to be negative 4. Okay? And then, oops, sorry, you can't see that. r of negative 4, if I go to my r function, negative 4 minus 2, okay, this is going to be the square root of negative 6. And again, we're running into a problem here where there's no real answer. So, same problem, doesn't really matter what order. However, we are getting different results there. So now we know that there is an issue with the domain. So let's take a look here. Determine the domain and range of r of s of x here. So this is r evaluated at s of x. So I'm going to take the s function and plug that in. So this is going to be r of 2x. Okay? And so I will plug that in. This will become the square root of 2x minus 2. Okay, now I want to determine the domain of that. So 2x minus 2. To figure out the domain, this has to be greater than or equal to 0. So bring the 2 over. It has to be greater than or equal to 2. X has to be greater than or equal to 1. Okay? Now, if that's true, actually, I'm sorry, so there's my domain. I should say it like this. This is my domain. The domain is going to be the set of x values such that x is greater than or equal to 1. Now, my range here, just take a quick look at this function here. Take out the 2, x minus 1. This is a radical function that's been undergone a horizontal stretch by a factor of a half and a horizontal translation 1 to the right. Neither one of those is going to affect the range here, so I can state that my range will be the same as any other radical function greater than or equal to 0. Okay. Now let's just see really quickly how this affects this question if I change the order of the s and the r here. So s of r of x will be s of, in this case, this will be root x minus 2. Okay, and the s function just tells me to multiply that by 2, so it will be 2 root x minus 2. Now the domain here is only affected by what's underneath the radical sign. So x minus 2 has to be greater than or equal to 0, so x has to be greater than or equal to 2. There's my domain. Set of x values such that x is greater than or equal to 2. And now let's just take a quick look at this. This function here, the 2 out front, is a vertical stretch by a factor of 2. Well, think about what your radical function looks like. That's not going to affect the range of that. Moving it 2 to the right will also not affect the range. So the range is going to stay greater than or equal to 0. Whoops, can't see that. So those are your domain and range, okay? And you can see that the difference there, it does change if you change the order. The function is different.